Today we are going to see a very important topic from physics, that is motion chapter. Motion is nothing but the change in the position with respect to the time. So it is related with the distance and displacement. So remember, there is if any point A and B, the shortest distance between them or the shortest path between them is known as displacement, and the actual path to move from A point to B point is known as the distance. So here is the difference. We'll understand it one more time. Motion is nothing but movement of any object with respect to time. So definition of motion is the change in position of any object with respect to its time. So this motion is the change in position of any object with respect to the time. So if there is an object A and object B, an object in the point A, an object in the point B. So the object from point A should move to the object point B. There is an actual path. That actual path from A to B point is known as its distance between them, and the shortest distance which can be covered is the displacement between them. Now the distance will be equal to displacement in case of the point A and B is having straight line as distance. So in this case the displacement and the distance will remain same. Also, one more concept is that in a circular motion, here is a point A and here is a point B. If this is the distance between the A and B, then this half portion which I am highlighting in red color is the displacement. That is, the shortest path will be the displacement. Hope this is clear. Now we'll move to the types of motion, which is uniform motion and non-uniform motion. So if we draw a graph between the distance traveled and the time taken, in uniform motion the distance traveled with time taken will be a straight line, whereas for non-uniform motion it is curved line. Why? Because it is not it's not moving constantly, the motion is not constant. The next concept is that if no change in position of the object with respect to time, then that position is called as rest. So any object remains in rest unless we apply any external force. So if object travels in straight line, the distance and displacement remain same, and we observed for circular motion the half of the that is the point A and point B, the half of the path will be the displacement and the whole will be the distance. So hope all these concepts are clear. Now we will move on to a short topic, that is speed. So speed is equal to distance with respect to time. So speed is equal to distance by time. So we'll see the laws of motion given by Newton. So Newton's laws of motion, there are totally 3 laws of motion. So out of which we'll be learning each of them. So law of inertia, it is the first law. It defines that any object in rest will remain in rest until we apply an external force. Similarly, any object in motion will continue its form in motion unless we apply any external force. Say for example, if there is an object lying on a table, so this is a table and there is a book on this object, unless we apply some external force, this book will not move. It will remain in its position of rest. So it's already in rest, it will remain in rest until we apply an external force. So this is the first concept. The second concept we can understand with help of a moving bus. So inside a bus, if the bus is putting a sudden brake, if the driver is putting a sudden brake and if the bus is being stopped, the one who travels inside this bus will go to the reverse. So you have observed this while traveling in a bus or car or train, that you will experience a backward force. It is a kind of opposite force that is due to the ability of law of inertia, that is the ability of the object to remain in its motion or in its rest form when until and unless an external force is being applied to that object. So the next law is the law of force. So force is directly proportional to the rate of change of momentum. Momentum can be written as, so momentum formula is P is equals to mass into velocity. So here force is directly proportional to momentum. So force is directly proportional to dp by rate of change of momentum, right? So it's not directly proportional to momentum, it is directly proportional to the rate of change of momentum. So if for this p we can apply f is directly proportional to d into mv divided by dt. So this velocity by time can be written as, you can take out the mass and write it like this, dv by dt. So velocity by time, as we already know, it is known as the acceleration. So we can substitute here f is directly proportional to ma, that is f is equals to ma. So force is equals to mass into acceleration, that is the second law. Force is equals to mass into acceleration. Coming to the law of action, it is very simple. Every action has equal and opposite reaction. So if there is any action, for that there is an equal and opposite reaction. The equal and opposite reaction means that, say for example, I am putting a force here of 10 Newton. So this object will move forward to 10 Newton. So the value is same. The action and reaction, the value is same, but the direction is different. So that is what we need to understand here. So the value remains same, but the action remains in the negative state. Next, coming to the motion graphs, here we can see distance time graph and velocity time graph, where you can observe there is three types of motion, that is uniform motion, non-uniform motion and rest condition. So in distance time we can see the uniform motion is a straight line and curved line for non-uniform speed or velocity. So the slope is here speed and velocity, and in the rest form the object remains in rest, there is no change in the position. Whereas in the velocity time graph there is a short difference here. You need to understand that uniform motion and non-uniform motion are same, but for there is no rest position for velocity time graph. There is only constant velocity. So the straight line which we are representing here is not in the rest position but the constant velocity. For velocity time graph there is no rest position. So the slope used here is acceleration. The slope used in distance time graph is speed or velocity. Next, here are some types of motion being mentioned. First type is the vibratory motion, which we can observe in the river or water current. Next is the push or pull, any force applied to object or doors or something to move an object, there is a linear motion. Then parabolic path, that is if we throw any ball that moves in a trajectory parabolic path, that is curvilinear motion. The oscillation of a pendulum is known as the oscillatory motion, to and fro movement, back forth movement. Then the rotation of earth is the circular motion. So the rotatory motion, for example fan. So like that, these are the types of motion and its example. Now next, the speed time graph of an object in a straight line, which of the following statements can be concluded? So here there is a question that mentions the speed and time graph of an object is a straight line. So when an object remains in rest or it is in uniform motion, only then the graph will be a straight line. Unless and until it is in uniform non-uniform motion, the graph remains straight line. So there are four options given. The motion of the object is uniform, yes it is straight line. Motion of object is rest, okay, then also the graph remains straight line. The motion of object is non-uniform, no, here the curve shape comes, not straight line. The motion of object is random, here also the graph will not be straight line. So the option is A and B are the correct answer. Next, we are going to next topic of physics, that is electricity. So electricity is nothing but the rate of flow of electron, but before understanding this we need to understand the structure of an atom. So the basic structure of an atom is like this. So inside The nucleus, there is presence of neutron and proton. So outer orbit or the shell will contain the electron. So when the electron gets excited, it moves from the ground state to excited state, and that flow of electron will lead to electricity. Now we are going to see about the liquid conductor. So we know conductor is any material or object that helps for the flow of electron through the body. So it allows the flow of electrons through it, through the material. So there are liquid conductors too. So some chemical solutions like tap water, salt water, vinegar, lemon juice are examples for the good conductors, whereas poor conductors are those like with a high viscosity, just like honey, all this oil, all these are poor conductors of electricity. Now coming to another concept, that is resistance is the blocking of flow of current. So it is opposite to conductivity. So resistance is responsible for the earthing, and it is used in the fuse wires for earthing purpose and safety purposes. So it is the opposite of conduction, that is it is just like the block of conduction. So if we see, resistance can be connected in two methods, that is series and parallel. So series are like just this symbol of resistance. If you are connecting it in a straight line, then that is known as series connection. If you are connecting it in the branches, then that is known as parallel connection. So this is the difference between series and parallel connection, where in the series connection the current remains same and the potential difference is not same, whereas in the parallel connection current splits up into three branches. You can observe in this diagram. The current which is being passed here is splitting up into three branches, I1, I2 and I3, whereas the potential difference, it remains same. Here V equal to IR, here also V equal to IR is the formula for Ohm's law. So in home, for the domestic purposes, generally parallel circuit is recommended. Why? Because when one circuit the current is cut off, the other circuits does not get affected, whereas in series, if current is flowing through this, one circuit is affected, the entire circuit is going to be affected. Hence for domestic purposes we prefer parallel circuits. So the difference between maximum and minimum resistance that can be obtained by connecting three resistance of 1/3 ohm each is. So this is a problem. Before solving that, maximum resistance is connected always in series and minimum is always connected in parallel. So the formula for series connection is that Rs is equals to R1 plus R2 plus R3, or how many resistances there, we can directly add it. Whereas the formula for parallel is that 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. After this you will put this in the reversed way. That's why you will get the proper answer. Now we'll observe. So 1/3 connected in series will be answer 1, that is going to be the maximum resistance. So 1/3 connected in parallel can be written as 3/1 like this. You will get 9/1. So you will write it as 1/9. Okay, 1 by Rp is equals to 9/1. So Rp is equals to the reverse of this, that is 1/9. So the maximum resistance that is in the series is 1, and then parallel, that is the minimum resistance, is 1/9. So you can just solve it and get the answer 8/9 ohm. So ohm is the unit for resistance. Friction. And now coming to another topic, that is frictional force. This is the opposite force. So any force which is acting opposite to the current force which is present on an object is known as a frictional force. So it is caused by irregularities in the surface. Say for example, in a rough surface the friction is more, whereas in the smooth surface the friction is less. So in a slope where students used to slide, the friction is less, hence they are able to slide well. So why? Because the surface is smooth and polished surface. So it is a contact force. So there is difference between contact and non-contact forces. First we will understand that contact and non-contact forces. Contact force are those which have direct contact with the object. For example, frictional force. Whereas non-contact force are example magnetic force. So here north and south, so there is no proper connection or there is attraction between these two, but the connection here is not in contact. So that is known as the contact and non-contact forces. The next is the applications. Walking, slip, not without slipping, we are able to walk. The grip is there, and for writing purposes, holding, lightening a matchstick, or for all these, we need the frictional force. The next is to reduce friction in any substance. We need to use a kind of lubricants. That is, example, grease or oil. Now we'll see the types of frictional force. What are the types of frictional force present? That is static, sliding and rolling. So the static, that is in the rest position. For example, we'll draw again a table. So on the top of the table a book or a ball is present, means there is already gravitational force which is pulling this book downwards. So and then balanced force is being acting on this. So if a question is being asked that the forces acting on this ball is what? So at a static period, what kind of forces are acting? So you should put a pair of balanced forces, only then it is able to sit